All right. Who here has ever heard of the CNCF project called Vitess? Oh, it's actually more than I expected. That's nice to see. But still a small fraction of the people that are here. So my primary goal with this talk is just to help raise awareness of Vitess. We'll talk about what it is and why it might be interesting, so that in the future, when you encounter a use case that might be ideal for Vitess, Vitess will pop up in the back of your mind. You'll say, hey, I remember this thing this weird-looking guy at KubeCon a while back was talking about. Sounded like it might be a good fit for this. We should check that out. So my name is Matt Lord, and I'm a Vitess maintainer. Sorry, I got to stay over here. I'm usually hand-wavy, so I got to get used to standing still. And I work at PlanetScale. As far as what Vitess is, so Vitess is a cloud-native database. A Kubernetes operator is a key part of the project. It's massively scalable, and we'll talk about the details of what makes it so highly available and MySQL compatible. So what this means really, what the value proposition is that you have this scalable data layer, which allows you to have virtually unlimited scaling of your data storage layer itself, but also helps you scale your operations team. So the team of humans that are actually operating these systems. And it gives the users of your systems, whether they are internal or external, the same user experience that they're used to with just a single MySQL instance. So the same MySQL that they would be using on their laptop or desktop for the development, they have that same type of experience when they're interfacing with your production data layer. On top of just being MySQL compatible and allowing you to scale, it has a lot of very nice features on top of that. So of course, being able to shard and reshard your data. So once your data set reaches a point where it's very difficult, if not impossible at some point, to manage that on a single machine, you start to partition that data. You create chunks of that data, so you'll shard that data, and then eventually you may need to reshard it. Maybe some of those shards can be combined, some of them need to be split, and so on. So it gives you nice workflows in order to manage that. Things like materializations, so materialized views across this large distributed data set that's managed by this massive cluster. Online schema changes, so being able to manage schema changes across this large distributed system in a way that's easily controlled. So you can say that you always want to defer to production traffic, that you only want cutovers to happen at 2 a.m., for example, and it gives you a lot of visibility and control around these things. Backup and recovery, of course, is an important thing, and it gives you a lot of easy options for that, and a lot of other things that we're going to talk a bit more that just allow you to scale. You can see an example of some people that are using it in Vitess, or using Vitess in production today. This is just a sample of those, and I wanted to give you an idea of how you are likely interacting with Vitess in your daily life without probably realizing it. So when you first wake up in the morning and you send a Slack message to your team saying, hey, I'm going to be working on X, Y, Z today, or I'm headed into the office, you're interfacing with Vitess. When you stop and get a coffee and they have a Square terminal, you're interfacing with Vitess, or maybe they're using Shopify. Again, you would be interfacing with Vitess. And once you get into the office and you open up a GitHub PR or a GitHub issue, again, you're interfacing with Vitess. So this is just a sample of companies at a very large scale that are using Vitess in production today, and that I hope give you some confidence to try it out yourself when you encounter hopefully an ideal use case. So some of the principles and features that allow us to help you scale is isolation. So we have a shared nothing architecture. Each shard is managed by a MySQL replica set. So you have a primary and any number of replicas. Those replicas will be spread across AZs typically, and they all have copies of your data. So they can serve reads. They're there to be able to take over serving writes for that shard. And so it gives you a lot of protection from isolated failures. Consolidation and pooling. So if you have a very hot piece of data suddenly, some news event happens. It used to be called the Bieber effect. Bieber is not so popular anymore, so I don't know what it would be called. But if you have thousands, tens of thousands, a million requests for a piece of data that come in at the same time, you can actually share the response with the same response from the database side with all of those requesting clients. We will try our best to do graceful degradation whenever we can, meaning that whenever we can serve your full set of traffic with slightly elevated latency, we'll do that. And that includes, so when there's a failure, let's say, we will detect that, or Vitess will detect that. It will attempt to promote one of the replicas, and it will pause traffic as that cutover happens, and then let that traffic go through. So there will be a slightly elevated period of latency, but no client errors. Being able to then implement things that will load shed and various circuit breakers, if you will, when you get beyond that point in order to keep the system healthy are also in place. So throttling, back pressure, load shedding, and so on. It's very observable. Of course, that's pretty key when you're operating a large system at scale, and highly available, as we've talked about already. All right, I barely went over. Hopefully this piqued your interest. If you have more questions, come by the project booth that's in the pavilion, the Vitess project booth. I will be there along with Florent, who will also be doing the maintainer talk with me on Wednesday. And visit the Vitess.io website. All right, thanks.